Hey everyone, and welcome. Today, we're going to go back to basics with something we all remember from school, the number line. But this isn't just a trip down memory lane. Nope, we're going to use it to dig up a surprisingly powerful idea that's been hiding in plain sight this whole time. All right, let's kick things off with a little thought experiment. You look at your bank account and see a $38 credit. Nice! Then, later, you see a $38 debit. Ouch! Not so great. Now, one is a gain, the other is a loss. They feel like total opposites, right? But what's the one thing they have in common? It's that number, $38. This idea, the difference between the amount and the direction, is going to be super important, so just keep it in the back of your mind. So to really get a handle on this, we're going to build our own little universe, a very simple, one-dimensional world. And I want you to imagine it less like a boring math tool and more like a map for a journey.
Okay, first thing any map needs is a path. And here it is. A straight line that just goes on forever and ever in both directions. This is it. This is the entire landscape of our world. Pretty simple, huh?
Every journey needs a starting point, right? A "you are here" marker. We're going to put one right smack in the middle and call it 0. Think of this as our home base. Every single trip we take, no matter what, is going to start from here. It's our origin, our point of reference for everything.
Now, what's really cool about this map is that there are only two ways to go. Any movement to the right of home base, well, that's a journey into positive territory. And any movement to the left, you guessed it, that's a journey into the negative zone. Every single point on this line has its own unique number, its own perfect address.
Okay, so we've got our map all set up. Let's actually take a couple of trips. And as you're about to see, some journeys are, well, they're kind of like looking in a mirror. Imagine you take a walk 4 units to the right, and you land at positive 4. Great. Now you come all the way back to home base and take another trip. This time you walk 4 units to the left, ending up at negative 4. The destinations are different, sure, but wasn't the journey itself kind of the same? I mean, you took the exact same number of steps, just in opposite directions.
And bam, that right there is what we call opposite numbers. They're perfect mirror images of each other. The most important thing about them is that they are the exact same distance from 0, just on opposite sides of it. So plus 4 and minus 4 are opposites. Plus 20 and minus 20, they're opposites too.
And trust me, this isn't just some abstract math concept. You see this everywhere. A deposit of $25 versus a loss of $25. A mountain peak 3,500 feet above sea level and a deep sea trench 3,500 feet below it. A positive atomic charge versus a negative one. In every single case, you have a direction, a plus or a minus, an up or a down, and you have a magnitude, a size.
So we've got these two key ingredients, direction and distance. But what if we only cared about one of them? This question right here brings us to the whole point of this explainer.
Let's ask a totally new kind of question. How far is positive 4 from our home base? Well, it's 4 units away. Okay, how far is negative 4 from home base? It's also 4 units away. What if we wanted a way to ask only about that distance, that pure, directionless number?
And we actually have a name for this. It's called absolute value. It's simply the distance from a number to 0 on our number line. And here's the key. Since distance can't be negative, the absolute value is always positive. Or, 0 if you haven't gone anywhere.
So mathematicians needed a clean, simple way to write this question down. Back in 1841, a guy named Karl Weierstrass came up with this notation: 2 simple vertical bars around a number. When you see this, it's not just decoration. It's a command. It's asking, what is the fundamental distance of this number from 0, ignoring its direction? Just the distance, please. Let's run through a few examples just to make this crystal clear. The absolute value of 10? Well, it's 10 units from 0, so it's 10. The absolute value of negative 8? It's 8 units away from 0, so it's 8. The absolute value of negative 3.7? You got it, it's 3.7. See the pattern? Taking the absolute value is like stripping away the negative sign, leaving you with just the pure size, the pure magnitude of the number. Now, this is where this tool becomes incredibly useful. It's not just for measuring the distance back to home base. We can use it to measure the distance between any 2 points on our line. It's like a universal ruler. And it's essential in fields like physics for calculating speed, which is really just the absolute value of velocity, or in statistics for measuring error, where how far off your guess was matters way more than which direction you were off in.
And the formula is beautifully simple. The distance between any two numbers, let's just call them A and B, is the absolute value of their difference. That's it, A minus B. This one little formula lets us find the exact number of units between any two locations on our map, no matter where they are.
Let's walk through one real quick. What's the distance between -7 and -3? Okay, step 1. We find the difference. -7 minus -3 gives us -4. Step 2, now we apply our tool. We take the absolute value of that -4, and the result? Boom, 4. So the distance between -7 and -3 on the number line is exactly 4 units. Simple, clean, and it always gives you a positive distance.
So let's bring all this home. We've been on this little journey through positives and negatives, but what's the big takeaway here? It's all about knowing when to focus on the size, the magnitude, instead of the direction.
This quote really just says it all, doesn't it? At its heart, that's what we've been exploring this whole time. Absolute value is a way to boil a number down to its purest essence, its size, its scale, its distance from the origin. And here are the most important properties to remember. First, it is never negative. Distance is always positive. Second, opposite numbers, like our friends +4 and -4, they always have the same absolute value. And finally, its entire job is to measure size, or what we call magnitude, a concept that's absolutely essential for everything from engineering to scientific polls. So, I'll leave you with this question to think about. We live in a world that is full of ups and downs, profits and losses going forwards and backwards. But when does it become more important to just ignore the direction and focus only on the sheer size of the change? That is the power of absolute value.